Yeah, so we're here today to talk about the what and the why and the how of serverless. I'm David Wells, work at Serverless. I'm going to be talking today, it's mainly about the concept of serverless, has nothing to do with the company. It's more the idea and the power that it gives the front-end developer. So we already saw, who here knows about Lambda? Already saw the hands. Awesome. That's cool. So we'll start with like some brief history of like how we actually got here and how functions as a service actually came about. So first, way back in the day, we would build our own machines, build our servers, put them in our own warehouse. It was super expensive to actually build an app at scale. And as time progresses, it got a little bit easier. We could, instead of building our own building and putting our own infrastructure in there, we could actually rent space in someone else's server farm. Then we could actually run virtual machines in the cloud, commonly referred to as VMs. Then the whole kind of Docker craze came about, and now we can run containers. So you can ship around things, kind of package things up nicely, put them in the cloud of your choice. Everything's getting easier and easier and easier. The next kind of logical place is running functions on demand, and we'll go into what that means and the kind of benefits that come about with that. So yeah, so let's dive a little bit. Why is this progression kind of going that way? Why is serverless actually a thing? So scaling servers is oh boy. Oh no, access denied. Oh no, my server crashed. Oh geez, Bluehost is down again. Oh no, K-pop star took down my site. Oh boy. So really, scaling servers is hard. Like at the end of the day, if you're doing something at scale, at a production scale for like the mass of the internet, scaling this stuff is not a non-trivial problem that requires like specialized teams, aka DevOps, to actually do that stuff. If you take anything away from this talk, this is the main point. This is a quotable. Please tweet, please tweet this. But really, like when you run your own servers, you have to think about load balancing. Is my server secure? Is it patched for the latest vulnerability XYZ? How am I doing monitoring? How am I doing logging? How am I like replicating my database? How am I replicating my application and like splitting the load between those? And then finally, like what are the costs associated with that? Am I running a bunch of idle servers somewhere that I don't know about? Is it expensive? Probably. You get into this place where it's like, WTF, I just want to build my application. I don't care about any of this stuff. So I found myself in this situation where I didn't want to deal with servers anymore. So here's the server farm. We're moving into serverless. Wow. Okay, just kidding. Lulz. So basically, it's not the point. The point isn't that there are no servers. At the end of the day, there absolutely are servers. The point is that they're abstracted away from you, the developer, and now it's like in the given cloud provider doing all that stuff for you on your behalf. And I would challenge you with like, is wireless internet really wireless, or somewhere in the room is there a router plugged into a wire? It's just abstracted away from you. And is the cloud actually a cloud? Yes, but we'll talk about that in another talk. So let's actually take a look at what serverless entails. Yeah, so about in 2014, AWS came out with a service called Lambda. Lambda is basically a way to run a function on demand that will auto-scale for you and a bunch of other things that we'll get into. How many people have heard of Lambda or used Lambda? Okay, awesome. Wow, a lot of people. Cool. So serverless in a nutshell, as an overarching concept, again, not the company. We just like it was, if you're gonna buy a domain name, buy the name of the industry that you're in, and you'll get free traffic forever. That's a growth hack, another conference. But basically, what serverless is running code on demand in a cloud of your choice with these following characteristics. So pay-per-execution pricing. You never pay for idle servers. It'll auto-scale for you. It has this concept of event-driven workflows. And there's also this idea of leveraging third-party services. So instead of like building your own mail server, you would use something like Mandrill or SendGrid or something like that. Instead of building your own telecom SMS service, you'd use something like Twilio. So like you really want to focus on your core competencies of your business, not building these kind of like pieces of glue code or glue services. But yeah, and really to stress the point, it's that pay-per-execution pricing model where if your code is not running, you're not being charged for it. So if you're running Docker containers or if you're running an app on Heroku or you name it, like you're still paying hourly for that box, even if no one is touching it. So that's like a huge difference. There are many, many, many places that you can run your code. All of the big players are in there: AWS, Microsoft, IBM, Google, WebZero, or Auth0 Webtask, Oracle functions. You can also run stuff in Kubernetes if you have your own cluster. Also, Netlify just announced today that they also have functions, so check that out. Okay, that's cool. Explain it to me like I'm 5, please. I'm glad one person liked that slide. All right, so you write your code like as you normally do. Lambda supports a number of different runtimes. Obviously, a lot of people here are JavaScript developers, so you just write your node code as usual. Install any NPM dependency that you want. Zip it up and pipe it into the cloud, deploy it. Sit back and relax because you're not going to be paying for it if it's not running. And yeah, you don't need to really worry about scaling. As Brian mentioned, the first 1 million requests per month are free. Yeah, so you could actually get away with like a lot under the free tier. It's also worth noting that all of the providers that I mentioned have a pretty generous free tier. So just trying this stuff out is crazy simple. And by the way, we don't make any money. We're a startup. This is like you pay AWS money or whatever cloud provider money. Yeah, like I mentioned, it'll auto-scale for you, and it gives you like the front-end developer, which I didn't go into background of me, but I was a front-end developer for about 6 years here, and recently moved into the back-end space about 1.5 years ago. And it was mainly because of the problems I was facing with like I couldn't scale an application. I didn't want to go really, really heavy into the DevOps world. I tried using Docker and containers. It's pretty complex when you get into it, especially with load balancing and all that stuff that I mentioned. So when I heard about serverless as a concept, it just immediately struck me as this is what I need. Shut up and take my money. I should have that picture, but I don't. So yeah, so really at the end of the day, in my opinion, serverless kind of gives the front-end developer superpowers where you can build stuff. If no one uses it, you're not paying it for anything. If people do use it, like you don't need to worry about those scaling issues. So yeah. So what can you actually use it for? We're probably used to building express applications or what have you. The use cases, really a ton of different ones. You can build, one of the main use cases that we see is building web and mobile backend APIs. You can do image processing. You can do web scraping. You can run a headless Chrome browser inside of a Lambda function. You can set up cron jobs. So this is like a huge way to save money. Like you don't need a server sitting somewhere, just sitting idly for that cron to hit. You can run those scheduled tasks only when you need to and only pay for the millisecond execution of that code. As well as I kind of mentioned that this event-driven kind of ecosystem where you can respond to different pieces of infrastructure events, like an S3 bucket upload. A user uploaded their profile image into an S3 bucket that can actually trigger a function to resize it for you and put it into another bucket. Or a new user is added into the user's DynamoDB table that can trigger a function that basically sends them a welcome email, for example, instead of wiring up all that logic yourself. So really, you can use your imagination to do anything, and like really, really anything, with the caveat of your function must complete in under 5 minutes. If it is a longer running process, that typically might be better served in a container. You can recursively call Lambda functions. They're not advisable, but you can do that. Tons of huge companies, I'm not going to go into this, are actually using this in production today. Tons of Lambda functions out there. How do we get started? How do we get our feet wet? So it's super easy to get started. Simple plug and play, especially with one function. You write a simple node function and zip up the function and all of its node modules if you are using any dependencies. Upload that to the cloud provider of your choice, and then profit. Doing that with one function is super easy. You can do it through the UI of your given cloud provider, but that quickly becomes challenging when you're building out larger and larger systems in a microservices-based approach. So you want to basically, you need a deployment tool to kind of keep it sane. You can try to roll your own. You can write your own bash scripts, et cetera. There are a ton of frameworks out there. It's really up to you what to choose. All of these are open source, including the tool that we have. It's a CLI tool. It's a serverless framework where basically it will take your code, package and deploy it for you into the cloud of your choice. So we're just going to run through real quickly what that looks like. And it goes in line with an idea that's called infrastructure as code, where you write your application and your infrastructure, where you can deploy it as many times as you want, and nothing strange will happen. It'll be the same exact thing every single time. So this is what a project looks like. You have your simple, you have your handler.js, and you have a configuration file called serverless.yaml. Inside of the configuration file, you have the name of the service. Underneath the provider here, we have, hey, we want to put this in AWS, and the runtime is Node. This is an older slide. Newer versions of Node are supported. So we say where we want it to run, what we want it to run. So we want to run a function exported from that handler.js file, and then when we want to run it. What event is going to trigger that function? So in this instance, we're running this function on an HTTP post event. So when someone hits my endpoint of /SaveUser with a post, we're going to run the SaveUser function. And then likewise down here, it's another function where basically it's going to run the function make thumbnail when the event S3 object created is triggered on our S3 bucket. And we can see our bucket name there. So there are a huge number of event sources. This talk is mainly focused around AWS, but all providers offer similar things where you can really listen to things happening in your actual infrastructure and trigger logic from that. And then you can also, if you need an additional database or an additional bucket or any other piece of infrastructure, you can bring that as well by defining that in resources. That gets transpiled down into something that's called CloudFormation. It's AWS's infrastructure as code language. This is probably 10% of what the CloudFormation actually looks like from that serverless.yaml file. So we're basically like an abstraction layer on top of that that'll write all of this CloudFormation for you, which is pretty complex if you get into it. And then you simply deploy it with serverless deploy. SLS is shorthand for serverless. It'll package up, it'll zip up all the dependencies for you, deploy the code, and then return back your live endpoints. So that live endpoint is I can plug into my React application and use Axios or whatever Ajax library you're using, and I can hit that as many times as I want, and I don't need to worry about the server getting slow or whatever. What happens is AWS will spin up concurrent functions to handle any load. So this makes me a happy camper or dog, princess dog. And again, it's this idea of infrastructure as code. So real quick, what are some patterns? What do they look like? So I mentioned backend APIs. So this is a real simple SaaS webhook listener. So you can set up a GitHub webhook to trigger a Lambda function. to save something in a DynamoDB as an example. This, again, just sits there idly until something happens in your GitHub repo and then triggers that function instead of having to provision a server to do that. So this opens up, like, not this example, but really all the examples open up a world of, like, now I can do this because I don't need to talk to my boss to get permission to get $8 a month to run this server. You can literally provision as many things as you want, and it's likely going to be free or close to free, depending on the scale in which you're running this stuff. Another example here is just a simple REST API where I'm just hitting a couple of different Lambda functions, again, saving something into a database. For all the GraphQL fans out there, this is a GraphQL pattern that we see where a GraphQL schema sits in front of, and it resolves to different Lambda functions or third-party sources. Getting a little bit more complex, this is actually, in the slides, the link to the slides I'll show at the end. But this is a working application with protected routes, React front end. It's a way to listen to form submissions. This is what we use to gather all form submissions on our site. Getting a little bit more complex, as your service grows, you have more and more functions or microservices. This is actually a replica of MailChimp that's like running at like a fraction of the cost. Again, the link's in there. And you know, this can get super, super complex. This is an entire social network built with different pieces of different microservices. Highly recommend checking this out if you're wondering how to actually kind of scale these things out. So infrastructure event-driven apps that like I talked about. We talked about the S3 bucket, triggering Lambda functions. This will trigger a Lambda function, talk to AWS Recognition, which is their facial recognition engine, and put emojis on people's faces. Silly, but you could imagine using that for something else. The DynamoDB example we talked about as well. So any update, insert, or delete on my table, I can trigger a Lambda function. So again, like a marketing, hey, welcome email, or database replication, or use your imagination. Yeah, tons of different things out there. So moving along, because we have 3 minutes, there's a lot here. Again, the slides will be online. So serverless fan out. So you can, again, spin up as many concurrent Lambdas as you want. So what this allows you to do is actually cut down batch jobs tremendously. So this is a real quick example of someone who took a web scraping job that used to take 8 hours and cut it down to 4 minutes by moving into Lambda function that basically would spin up concurrently the job and then spin back down. And then a lot of people use it for analytics and data processing. I'm going to skip over this one. I'm going to skip over this one. They're pretty cool. The Department of Defense is using some of my code, not to shoot missiles, but they're actually using that webhook example. I told my dad about that, and he said, "Oh, how much do they pay you?" I said, "That's not how open source works, Dad." But okay. Yeah, I'm not going to go into that. So there's a ton of examples out there. So we have at GitHub/serverless/examples, tons of different use cases out there. Yeah, really ranging from CRUD applications to how to set up cron jobs, how to set up GitHub webhook listeners, how to do that analytics, data processing, etc. I'm also giving a workshop, shameless self-plug, this Friday actually. So it's going to be a full day thing, walking through the entire kind of way to package and deploy these Lambda functions using the framework, and touching on a number of the different AWS services that you might use in a production application. But yeah, that's really it for me. We came under in 30 seconds, which is good. So I don't think we have time for questions, but the slides are right here. And if you have any questions about serverless, feel free to tweet me anytime or reach out to me. I love talking about this stuff. And yeah, if you use serverless, not us as a company, again, our framework's open source. You can use whatever framework that you want. As long as you're building things with functions and seeing those kind of cost and scaling benefits, that's kind of what I'm talking about. But yeah, thanks.